Hello everyone, my name is Brad Henson. In today's video, I want to go over the status of the hardware build for the K4 tent controller. So let's take a look. The idea is that each of these boxes will get mounted roughly in the orientation that you see here on some kind of piece of plywood, maybe with some offsets, either underneath the tank or behind the fish tank. This will give us easy access to all of our outlets and to our sensor plugins. On the face of each box, you'll see that all of our through-hole screws are countersunk, making for a nice smooth flat finish in case we want to add a graphic to the face in the future. On the control box, I have a case mount LED for power indication, and on the relay box we have that surge protection switch that came right out of the plug pack. If you're curious what kind of screws we're using, I picked these up at Lowe's. They're the number 4-40. I use the 1 inch and the 1/2 inch. I found this size works incredibly well with all the boards that I've needed to mount into cases. For a quick tour around the outside of the case, here on the control box on the bottom we have the USB adapter for the Arduino Mega, a network adapter for the network shield, a VGA connector for all the input-output pins, DC power input, and a manual switch. On the other side, the B and C connector for the pH sensor, and then 3 USB connectors which also go to the Arduino Mega for each of our sensors. We have temperature and 2 water level sensors. Now for the relay box, here on the bottom, again we have the VGA connector for the input-output pins, mains input, just a standard 3-prong cable, and then a total of 9 outlets. And of course we're only using an 8-channel relay. Well, you'll see when we open it up that 2 of the channels have been tied together. Now for the relay board, one of the first things you might notice is how densely packed the case is. It looks like a lot's going on, but I assure you it's pretty straightforward. Overall, we effectively have 3 major areas in this case. We have each of our outlet connections, the circuit board that we pulled out of the electrical outlet strip, and then of course the 8-channel relay. Now the 8-channel relay is connected to our input-output pins on the Arduino via these header cables. And what I've done is just taking a standard breadboard header cable, cut off the end, soldered it to the VGA connection, and then heat shrinked it in place. When everything is done and I'm satisfied with the build, I'll go back with hot snot and get in here and secure these connections a little bit more. Even though each of the channels on the relay board each have their own optocoupler to isolate or give you the ability to isolate the relay board from your Arduino, I'm running this in a common ground configuration and will be supplying power from the control box via the VGA cable to the relay board. The neutral line from the surge protector circuit board is fed in series to each of the outlets, and then the active line is fed to each of the relays. The thought process behind that is I didn't want an active or a voltage potential just sitting there waiting for a ground connection. And then of course the earth ground from mains input is also fed in series to each of our outlets. Now I initially wanted to have all of my splices as soldered connections between the wires. I quickly realized that that wasn't an efficient way of putting this box together, and so I had to come up with something else. As an alternative to soldering each splice, I found these push-in wire connectors. This package has 2, 3, and 4 inputs. Now the one problem was that these connectors are designed for solid core wire, and of course all of the wire that I'm using in my project here is stranded, and so I ended up just soldering the tip of each wire prior to placing it into each of the push connectors. Now all of the wiring throughout the case is a 14 gauge wire, color coordinated for the purpose, and then as usual I'm using the quick disconnects so that if I need to make modifications and pull stuff out of here, it won't be that hard to pull apart. Now for the control box, we have a little bit more controlled chaos, if you will. I was surprised at how quickly this box filled up once we started adding the Arduino and network shield and real-time clock, pH sensor, and then all of the various connectors. it became much more difficult to control the wiring in this case. In the future, I'm going to take a little bit more time to do some forethought in laying out the internal workings of my cases. Power is provided to the control box via DC jack. I'm using an external 7.5 volt class 2 transformer. That's connected to the primary switch for power, and then I'm using 2 of those push connector from the relay box as the bus for both the positive and negative side. All of our power cables here are using solid core 22 gauge, and then also, it's hard to see, I've got that case mount LED connected directly into each of those push-in connectors. Moving around the case, buried in here, it's hard to see, we have the real-time clock mounted, and then also the pH sensor with the BNC through hole from the case. Now, something that was really important to me was that once we had this mounted in place, to still have access to our normal USB connection for configuring the Arduino, uploading new firmware, things like that, and also our network connection. And so I'm using standard case mount cables, and I've just wound those up, zip tied them in place, and then made those standard connections to the Arduino and network shield. For each of the sensor connections, I've opted to go with USB connectors, and what I've done is taken the standard USB cable, cut it just about an inch from the connector, and then spliced in those breadboard cables, and then heat shrinked everything in place and zip tied it down. Now, I've been asked in the past what an effective method is for getting these nicely squared off through holes for our connectors, and the way I accomplish this is just using a regular drill bit to create a starter hole, and then a standard file, and filing it down to whatever shape I need. Now, you might notice that initially I've removed the female header pins on this network shield and replaced with male header pins so that I could solder directly to provide power to all of the circuit boards and then the 8-channel relay. After a little bit of experimentation, I found that this isn't going to be the best method, and so I've put on order a down converter so that I can mount another circuit board in here in line with the power. And so as the 7.5 volts, or really more like 9 volts coming in from the transformer, I'll be able to down convert it to the appropriate 5 volts, apply that to the 2 buses, and get power to each of the subcomponents, and then also the 8-channel relay through the VGA connector. And then the Arduino will still get powered separately directly from the input, and it'll regulate its own power down. Well, that's the build pretty much in a nutshell as of right now. If you have any questions, make sure you leave them down in the comments below. And if this video was helpful, make sure you press the like button. Catch you next time.